Today I'm going to be making some anhydrous nitric acid, an extremely strong oxidizer which is used in rocket fuel. The method I use typically yields around 99% pure nitric acid, so it's not completely anhydrous and there's around 1% water, but it's pretty good for most purposes. I begin by adding 100 grams of potassium nitrate to a conical flask. I then assemble this setup. On the left, I have a flask with potassium nitrate in it, which is set on a hot plate. On top of the flask, I have an addition funnel from which I will drip in concentrated sulfuric acid. On the right, I have a condenser which leads to a collection flask. The hose attached on the vacuum adapter leads to outside the window so I don't breathe in any nitric acid fumes. Once everything is ready, I start dripping in 55 milliliters of concentrated sulfuric acid through the addition funnel. Add it dropwise and slowly. As the sulfuric acid comes into contact with the potassium nitrate, it reacts to form nitric acid and potassium bisulfate. The heat generated is enough to make the nitric acid boil and reach the condenser. I added a stir bar, but as expected, it didn't work because of all the potassium bisulfate formed. I keep dripping in sulfuric acid until all the sulfuric acid was added. Once all the acid was added, it became liquid enough that the stir bar began to work. At this point, I turn on the hot plate and turn on the stirring. I also insulate the flask with some aluminum foil. Not long after, we start collecting yellow fuming nitric acid in the collection flask. The whole distillation setup is also filled with some light brown nitrogen dioxide gas. I distill to dryness, and as you can see in the distillation flask, I am left with a large clump of potassium bisulfate. The nitric acid is yellow due to dissolved nitrogen oxides. This is completely normal, and there's not really much you can do about it. However, it won't affect the properties of the nitric acid at all. Pure nitric acid boils at around 83 degrees Celsius, so the temperature in your thermometer should read around between 80 and 85 C. Once no more nitric acid comes over, I let everything cool down, and then I empty out my nitric acid into a proper bottle. The final yield of nitric acid was 38 milliliters, or around 57 grams, which corresponds to a 92% yield. This yield is crazy good, and I think this reaction is pretty efficient overall. I tested the density of the nitric acid, and it came out to be 1.49 grams per centimeter cubed. According to a chart I found online, at 30 degrees Celsius, which is my room temperature, this corresponds to 99.5% concentration. This concentration is crazy good, as well as the yield, and I'm quite happy with how everything turned out. You should notice as well that I was wearing vinyl gloves while I was changing out the receiver and handling the nitric acid. You must not use latex or nitrile gloves, as they will catch fire upon contact with the nitric acid. Above an 80% concentration, nitric acid is an extremely strong oxidizer, and will make a hole right through any lab glove. This is why it's recommended to stay without gloves when handling fuming nitric acid. If you have vinyl gloves, then that offers good protection, but if you don't have vinyl, it's much better to work without gloves. It's much more dangerous to get pure nitric acid on a latex glove or a nitrile glove than on your skin. If you get it on your skin, you have around 10 to 20 seconds to wash it off before it starts having damage, but on a latex or nitrile glove, it can catch fire within 2 or 3 seconds. Anyways, you may remember the chunk of potassium bisulfate that was left within the flask, and I didn't really have much use for it, but I decided to purify it anyways since it's a pretty useful reagent. I don't know how I purify it, but basically I just wash it a few times with methanol, ethanol, acetone, some organic solvents, and then I recrystallize it from some water. After recrystallizing it, it turned out a lot more white and clear than I expected, and I let it dry, and now I have some nice and pure potassium bisulfate. Ignore the stuff in the background, just don't worry about it. Anyways, in conclusion, this method gives really high yield and high concentration of nitric acid, which is pretty good, but you do need to handle hot concentrated sulfuric acid, which may not be viable for some amateur chemists. Quick note, if you dissolve the potassium nitrate in some water and add the sulfuric acid, you can make some azeotropic nitric acid, as long as you don't use too much water. I actually did this too, and I'm going to use the azeotropic nitric acid in a future synthesis project.